Hello. Hi guys, good morning. Welcome back to a new video. I hope you are doing good. In this we see problem longest ideal subsequence. Again, the problem is very easy. Again, easy as in it is linked to a previous concept which we have seen so many times. So it is simply saying that you are given a string S. Again, solving it in the most basic approach, it's easy to think, but writing the code can be a bit tricky, and also thinking of the optimization can also be a bit tricky. You are given a string S consisting of lowercase English letters which are from A to Z, small a to small z, and an integer k. Now I have, we call a string t as ideal. As you can easily see that I have to find the ideal longest subsequence. So I have to go, and firstly this string t should be a subsequence of my input string which is S. Okay, and also to make this string as ideal subsequence, I have to make sure that the absolute difference in the alphabet order of every two adjacent letters in T, which is a subsequence of S, is less than or equal to K. What it means is that, okay, take one by one. Take the first step, which means you have to generate, you have to take T as a subsequence of S. So if I gave you a string S and I ask you, bro, you have to make a subsequence of it, then what actually makes you think that what you can apply to make a subsequence? Okay, you will go on to every character and you will ask him, bro, can I take you or not take you? Let's say, okay, he will say you can take me. Then I will go on C, can I take you, not take you? Okay, I'll not take you. Then I go on to F. Okay, I can take him. Then I go on to G. Let's say I can take him. Then again, I'm showing there both the possibilities. You can either take it or you can ignore it. Okay, B, ignore it. D, let's ignore it. So this is AFT, AFG. It is one such a subsequence. Again, there can be many other subsequences in the order saying, okay, a character I can take it or not take it. So the first intuition here itself is, as soon as something came up as take not take, which means give not give, which means a 0-1 knapsack kind of problem can be formed. I am not saying generating a subsequence is a knapsack problem. Again, when I say knapsack, I mean actually a DP problem, but I'm saying, okay, it's an intuition. Maybe it can go in that direction because of the fact that we are taking a subsequence, and basically the operation here is take not take. It is same way linked to longest increasing subsequence problem, which we have already seen on our YouTube. Just write longest increasing subsequence by Aryan Mittal, you will get the video. Now, okay, we have got the intuition that maybe DP can be applied and maybe I have to find the subsequences. Next step it says is that absolute difference, again, absolute difference for this specific subsequence, which is a string T. This is a string T, this is a string S. So absolute difference in the alphabet order, okay, for every two adjacent letters in T is less than or equal to K. So these two difference should be less than or equal to K. So it is kind of that while I'm generating the subsequence itself, okay, because as I am at an index, I will ask my bro two options. Bro, can I take you or not take you? Right? But okay, even if the bro tells me, okay, bro, you can be taken, as in like I have two options, either I can take it or skip it. Either I can take it or skip it. Even if I'm about, again, if I even choose the option of taking it, then also I have to make another check that whatsoever I'm about to take right now and whatsoever previously I have taken. Again, previously I have taken in the string T, and string T is a subsequence. So it could have happened that I would have skipped F altogether. I would have maybe taken the last character as C. That's also possible. That here I have C. So I have to make sure that, okay, if I am at string, if I'm at that index I will ask my last character, whatever I have taken. Let's say here in this case I have taken C. I will ask my C, bro, is R difference, which means is G minus C. Again, make sure take the absolute difference. If that difference is actually less than or equal to K, if that is the case, only then I can actually take my character at ith index. Cool. So I realized that, okay, if I am at a specific index, okay, I have two options to take it or not take it, but still, even if I plan to take it, I will still have another check to just check the last character whatsoever I have taken in my subsequence, that is it actually difference is actually less than or equal to k. So I realized that to iterate on the entire, basically to iterate on the entire string, I need an index, and I will ask take not take. But on top of it, I also now figured out that I will also be needing the last character what I have taken. Aryan, why can't you take I minus 1? Because bro, I minus 1 will point to a character which is back, but it is not necessary that this is my last character of my subsequence. Subsequence last character can be this, any previous character. So it can happen that I might not even have taken F or G altogether. That is the reason I have to take, okay, what was the last character which I have taken. Okay, so this is the entire stuff which you have to do, which means you realize that you will go on to all the indexes just to iterate on the entire string. You also realize that you will need the last character whatsoever you have taken. Now we also realize that it was actually a take not take problem, which is actually the basic of our 0 knapsack, also called as a DP problem. Then in that we will simply write a recursion and then we will just memorize stuff. If we are simply writing the recursion, we know that a simple base case, again make sure how to determine the base cases, that what you are returning and what your function is doing. You have to return the, make sure you have to return the maximum length, return the length of the longest ideal string. So ideally I'm returning this maximum length. So if I have reached the end, right, there is no length specifically which I would be adding. I have reached the end. Okay, I am done. So if I am done, I will not add anything in my length. So I'll add a 0 in my length, so as to represent I'm not adding anything in my length. Okay, now for sure we will have a simple recursive like DP check, which means if DP of I comma last, if it is not equals to -1, then simply return DP of I and last. That's a simple DP check which we can have. But the actual main recursive case is simply taking or not taking it. And again, for taking it, okay, whenever I will take it, for sure my length will increase by 1 because I am taking some character and I want the longest increasing or longest ideal subsequence. Longest length I want. So if I'm taking some character, so length is increasing by 1. Okay. And for sure I will go on to next character. But then as I have taken this specific, again let's say this is the string S. I was at I. Let's see if I have taken this and if I'm moving on to I plus 1. So this I will actually become the last character for my I plus 1 going forward. So I will say that this S of I is actually my last character for I plus 1 and going forward. Okay, but I showed you this. Okay, you had two options to either take it or not take it, but you can only and only take if actually your S of I, which is what you are about to take, because you remember that you are about to take this S of I, it and the last character whatsoever you have taken last, that absolute difference should be less than or equal to k. Only then you can actually take this. Okay, let's say I have taken this, and for sure the obvious one, I will not take it, which means no length increased. I'll simply go on to my next character, and last will remain as it is because I have not taken. Again, it simply says that I have not taken the S of I. I moved on to my I plus 1, but the last character, it's still last itself, whatsoever I was passing earlier. Thus, whosoever give me maximum length, I will simply return that. Again, for sure, I will simply try to memorize it. I'll say DP of I comma last, simply return the maximum, and you can easily see my I will actually go in from 0 to n minus 1. So this length is n. My last is nothing but character, and I know I only have 26 lowercase English characters. So my time and space, both we can see it is simply O of n into 26. Now, there's a very important edge case which you are missing. It is that in the very beginning, my last is actually nothing technically in the very beginning. So if I just say that this is my entire string S, so I will have to call from my main function. From my main function, I will call in something, right? I will call in, okay, solve starting from the index 0 and something is your last. Starting on index 0, something is your last. But I know that I don't have any last in the very beginning itself. So I should pass in something which is saying, okay, I don't have any last. So either you can pass in any other character, maybe let's say I pass in star or hash or anything. Okay, if I will pass in my star, then I will have to put a check that, okay, if my last is actually, let's say, a star, or again, if it's a star, then directly go and take it, because it is the first time you are taking a character. And if you're taking a character for the first time, you don't have to compare it with the last altogether. So if it is a first time, if you're taking a character for the first time, just simply take it, right? Okay. If not, and for sure, if the last is not this, then for sure you can simply take your last. Like take whatsoever last you have, and then try to see if s of I minus last is less than or equal to k. Now, if you add this, make sure your last will no more be 26, because if you remembered, here you are actually saying that, again, here you are doing a last, but last is a character. Character is a ASCII value. So you have to make sure that in the last you do a last minus a to actually bring it to a 26 bound. Bring it to a 26 bound, because ASCII characters are big. Okay, like it can reach to 140, 150 something. So again, we can also take that if we want, but I'll say let's keep it short. Let's keep it 26 only. And on top of it, we will realize that, okay, this is star. I don't know what ASCII value this has. That's going to be a bit tricky. So we can maybe add more if conditions in that. Okay, if again, when I say if conditions, for memorization also I have to add some if conditions and stuff, just to make sure that if my last limit is 26, so any other arbitrary character, it might end up giving a runtime exception. So I figured out that, okay, if I am taking A to Z, ASCII values are 97 to 122. So I will for sure take a array, or basically my DP array, whose characters limit will be up to 26. Then I realized the next character itself is a open curly brace, which has the next index. So what I can do is I can take a length of 27, and then if I do a this minus a, I will be in the bounds of 27. So the same way I was doing here, last minus a, I was doing here last minus a while storing, so as to bring it in 26 bounds. Same way I will actually be able to also store my last, because I will just say it's a simple opening bracket. Again, there are multiple ways to solve it. You can add if conditions, you can maybe remove it altogether and add something else on top of it. It is just what I thought, okay, let's add maybe this. So in the very beginning, I can simply say that, okay, if my opening is a curly brace, then I'm good, I'm sorted. So you will see the code is very simple. I have taken n for my I, and I have taken 27 because I know I will also be handling my curly brace so that it doesn't give a runtime exception. Although it will not check it, although it will not store it, but it will still have a check, because you know the DP will still have a check. And if I will place any other character, it might end up giving a runtime exception. Although I can also place a if condition here itself. If not, then you can maybe change the logic here itself so as to handle it. But that is how I thought of, okay, let's handle it in very simple linear way. That's the reason I took a 27. I started from index 0. My last is opening curly brace. Again, you can take any character. You can also place the alphabetic characters, but make sure that you have to handle it at every point, because I'm not saying only in the very beginning. Only in the very beginning you will have this. It can also happen as only in the very beginning. It doesn't mean that only in the very beginning you will have take not take condition. This take not take will go for the entire string, which means it can be possible that, okay, you have not taken, you have not taken, you have not taken. This is the first time you are about to take a character. So for this, the last is still nothing. So it's the reason. So it's, and again, this can be a character G. This can be a character H. And if I will put my last as, let's say, A, and then if I compare A and H, and my case, let's say, only 2. So I will say, okay, please don't take H, because H minus last, which is A, it is having a higher difference while my k is small. So I should make sure that I should take a last as something as something which I can add as an if condition, that, okay, if this is the last, please take it. No matter what the number is, please take it. Because if last is some arbitrary character, which means I'm first time taking a character. And that's the reason this edge case makes this one a bit tricky. Now, very simple. Apart from it, simple base case of I equal to n, simply return a 0. Then simple take, not take. If last is a opening curly bracket, which is actually having a value of 123 just after my z, I know simple one fact that I can simply take this specific character no matter what. So I'll simply take it and solve it for I plus 1 and pass the current character as the last character for the next index. Or maybe if this is not true, if I already have some last from A to Z, then I will compare if that absolute difference is less than or equal to k. If that's the case, simply move on. Simply move on. So I'll simply move on and say that, bro, take the character and simply move on. If not, then anytime I have another option that to not even take it altogether. So if I will not take it, I'll simply solve for I plus 1 and I will pass my last, which I was getting previously itself, last. And then ultimately make sure to convert this last to an integer, because this last, if I will just only put last here like this, then it can have any value from 97 to 123. So I will have to put my this value as rather a 140 maybe to be on safe side, or maybe 130 I can also put. So as to not keep this all together, I will have to subtract my a so as to bring this in the bound of 27. Cool. And ultimately put the maximum length. That's how you can easily see that your time is O of n into 26, and for sure the space is also O of n into 26. Thus my both time and space is O of n into 26. Cool. Now this is the very basic, which again idea you should have been able to think. Code, I would say it might give you wrong answer because of the trickiness involved in taking last. But then now comes is that how to optimize it. How to optimize this code? Simple. Like time, there is highly unlikely we can optimize because whenever in a DP problem, whenever person asks us to optimize, we firstly until unless this is in bounds of the time complexity. As you can easily see, it will work in a time complexity. So we are sorted. If it would have been not in bounds of a time complexity, then we would have thinked of improvising the time. But here in this case, it seems like we'll have to go and check for the character, right? Space is taken O of n into 26. Can we improvise it? Maybe, maybe not. But that's a very tricky portion to even think of. Now, let's come back and see why this space of n into 26 is being used, right? Because we know it is being used. It is being used saying, okay, I'm using for n and last I'm using for 26. I simply says that, okay, I am at a specific index, and last simply considers that, okay, if I am at an index I, then last 26 characters, as I will consider the last 26 characters as the last characters. So if let's say this is the string, I, then I am technically considering all the last characters I can consume or I have consumed, but I also know in the back of my head that all of these last characters, which means up till this index, will all be lowercase characters, which means these all will be 26 characters. I know that fact from very basic stuff. That's the reason a space of 26 is used for the last one, because for all these characters in the previous indexes before I, all these will be 26 characters. I know. So on any one of them can be my last one, a good candidate. So I know that's the reason 26 space is being used. So, and which will actually give me maximum length. That's what give me maximum length. Now, if you had heard this very carefully, you must have realized one fact, that if I am a specific character, I will go on to the last characters whatsoever I have got so far, and in those last characters, again, I'm only concerned about the last characters. So I'm concerned about, okay, only A, C, B and D. I'm not concerned about A, C, C, B and D, because you see C is repeating twice. So I'm not concerned of what actually, what C is there. I want any last character which can give me maximum length. So I realized I'm not concerned about the character at that index. I'm only concerned about, okay, what is the maximum length for that character. That can be that can be confusing statement. It simply says, okay, if I am at a specific index, I wanted to look for last characters, right? And that is also what we are doing, that I will only go and check for a character, and I'm not concerned about this character at index C, sorry, this character C at index, let's say 1, or this character C at index, let's say 4, 1 2 3 4. I'm not concerned about which character at which index. I'm concerned about, okay, what is the character which can actually help me get my maximum length. So for this index I, for all these previous indexes, I'm not concerned about their index itself. I'm concerned about what's the character value. So I realize, okay, if I'm only concerned about the character value so as to give to my current index I, I'm only concerned about the character. I'm not concerned about their indexes. So I can easily say that, okay, just imagine that you have C is gone. Let's say you have one C, and that C gives you a length, okay, so far up till C, this is the maximum length. And then if C and E can form a pair, which means C and E absolute difference is less than or equal to K, then I can increase my length by 1. So I can easily say that at the current index I can say 1 plus dp of whatsoever my maximum answer would have given by C, right? So this is what I would have given. So you realized that again, for this, I will show the answer in dp of E. And thus the same way, this E will be used further on for, let's say, any other character, which means, let's say, H. So I will use this E for my H. I don't need the index of my E altogether. So I realized that this index I would not be needing. I would only need the maximum length contribution for a specific character. And I'll just try to maximize that every time. Which means both the C I had here. I don't want the index of that C. I just want whosoever has given maximum. So whatsoever dp of C I would be getting, I would actually be maximizing that dp of C. Okay, maximum of dp of C, comma, whatsoever maximum length I'm getting. So I'll always maximize that specific character contribution. No matter this index one or no matter this index one. Whosoever is there, index doesn't matter for me. I want for that character, what's the contribution? It should be maximum as possible. So that's the entire crux of how to improvise the space, that we don't want the contribution of that specific index. Now, for sure, in this top-down approach, we can never improvise space, because no matter what, even again, although it can be fast depending upon how many places it hits, but still we cannot technically touch it, because we cannot technically know which index he's actually placing on. So what we do, we simply know that what's happening above. We know that we are going on to all the indexes. And then I realized that I will only have to go on to all the characters which are previous to me. So I will go on to all the last characters. But Aryan, how would you know that they are previous to you or they are maybe ahead of you? Simple. By default, I initialized my DP array by 0. If it is behind me, then it would have been already computed, right? If it is after me, then it would have been by default 0. So that is the reason how I would actually cleverly use my DP to tell if something is behind or forward of me. So if I'm at an index, I want the contribution of all the character which is behind of me. Let's say A is here, B is here, A is here, and let's say C is here. I am at this character. And let's say again, afterwards also, I had a A, I had a C, I had a C, I had a, let's say, D. Then this A versus this A, both are different technically, right? How would I know? Because if I am iterating like this in this order, so these DB values would have been computed and these would be storing the contribution. Okay, for this A, which means, okay, for A, but whosoever gave me maximum value. But for all these in the right, it would not have been touched so far. Okay, great. So what I'll do, I will just simply go on to all the indexes. Let's say I'm at this index. I will go on track for all the last characters that can be from A to Z, right? Okay, from A to Z. Then I will check for that again S of I minus the last character, and I am only concerned about A, B, and C as last character. I'm not concerned about A, B, A, C. No, only the last character, which is A, B, or C. I will go if that absolute difference is less than or equal to K. Then I will try to maximize my length with that last character and just add a +1, because for sure up till B, if I had a maximum length and I am now making a link with the current character I, so a length of 1 has increased, so +1 for that. And I will try for all the possible last characters. Again, for example, for this D, you see it is not so far behind, so for this D my DP value will be a 0, and if I do a +1, it simply means that I'm only taking the character I. That's it, only one character, and that's a length of 1. That's awesome. So that is how this default value of DP will actually let me know what is behind and what is after me. And then ultimately, when I try for all the characters, I know that at this index I, what is the maximum length. But I also remembered that I don't want to go on the index level. I want to go on the character level. What is the character here? That character's maximum length I have to actually say, because I'm using that character's maximum length. My DP is choosing the maximum length for that specific character itself. So I will push in the maximum length for a character itself altogether. So the DP value here, I will actually say what is this. Again, I grab the character at that index, I will convert that to a 26 limit, and then I will simply go and update the maximum length for that character at index I. I'm not saying update the maximum length at index I. No, I'm saying update the maximum length for that character at index I. Cool. And ultimately, you know that for all the indexes, I have to get the maximum length, because it can happen that, okay, maybe maximum length is at this index, or maybe at ultimately in the end. So again, I have to, maybe you can do is, okay, do this entire iteration, and then ultimately in the end, update this maximum length by simply iterating on all the indexes again, or maybe all the characters again. That's one thing you can do. Or else I'll say ki while computing your, this is to compute a DP value, but out of all the DP values, whoso is giving maximum length is your answer. So this is the maximum length which you have computed, and that's what you will actually return as an answer, which means maximize the answer overall. So I'll maximize my answer overall and ultimately return the final answer. And that's how to solve it. Now, this one is actually a bit tricky. Again, I simply showed it because many people take it lightly, that how people just simply will go on to bottom up and will explain it like as if it is very simple. But I showed you the entire logic behind how you actually thought of removing the index altogether. Because see, index, if you have done DP problems, so DP of index is the very prime thing in the DP. You end up storing index altogether for sure in every DP problem. But this is a special one in which you are not storing the index, but you are storing only the character at that index. What for that character? What is the maximum length? Cool. I hope you guys got it. Bye bye. Take care.